Oh, it's tough. When you have a touch, you have to follow the traffic. If I were you guys, I would take this. This is what we're working on the next. Oh, I got 3 days on there, but it could be more. This is we're gonna work on going back and forth graphically between the original, the derivative, and the second derivative. So, like, the second derivative graph is positive. What does that mean about the original? First derivative graph is on the relative mid. What does that mean about the original? So all this different kind of stuff. This expected value thing is for stats. But then these other 3 chunks here are for you, and I would recommend writing on the back of this. Blank page back there.
Blank page.
And then we'll just start getting into it and see how it goes. Some people love this stuff. It's very much like in your head thinking through things, not like a step-by-step writing down algebra. Some people like that better, some people like it less. Everything except for the expected value and the date. You can write the date if you want. But like the other, all this stuff with the f and f prime and f double prime, that's all for you guys. So I can just like refer to it and point out what we're going through. Where's the rest of them? Thank you very much.
Wait, what about the C5?
What are you looking at? This one? F double prime of x crosses axis / changes signs equals POI. Point of inflection. Yeah, that was.
That's what Rich.
I had a water tank broke yesterday. They're putting it in like right now.
Well, you should have hired. I would have done it for good grade.
Well, the tank itself was pretty expensive. I gotta buy the tank though.
But I could like get it upstairs.
Have you done it before? It's not that bad.
Unless like the only thing like
I'm getting this kind of signal from my head.
it's water here. Get the same exact size, that's okay. But if you get a different size,
Those six,
the pipes are like different sizes, so then it doesn't like line up.
that's more of a pain.
So then you have to like solder.
Yeah. So I hadn't showered in like 4 days. I went out yesterday.
If it like lines up like pretty easily, then
It's not too bad.
it's kind of it's like
It's pretty heavy though, isn't it?
not well when it's empty.
Really? We still riding or we good? Raise your hand if you're still riding. Okay. So let me just review like the stuff that we have really talked about is these shapes that we did on the graphs before. So this graph shape is supposed to be f of x. So if f of x looks like this, that means the derivative is negative because the derivative tells us slope, negative slope. And the second derivative is positive because the slope itself, even though it's negative, is increasing. Like we're curving upwards. Over here, so f of x, this is f of x again, it is increasing. So it's got a positive derivative. And the slope is increasing itself. Like the slope of the slope is positive. Curving up, and that's what the second derivative is greater than 0 means concave up. These two are both concave down because they're curving down. And then this is f of x, the derivative is positive and the derivative is negative. So we're going to start connecting these from derivative graphs into the second derivative graphs, which just like shifts the way you think about it. It's just kind of a shift in your mindset. So I'm gonna skip over. This is gonna be super helpful, I think. But if I just read through it right now, you're gonna be like, "This is boring, stupid." So it's more of a reference that we'll look at later. Same with this. I think those are very helpful for you, but I don't think talking through them right now is a productive thing to do. So let's start with this is f of x. This is an original level graph. So there's 3 levels. There's original, there's derivative, there's secondary. This is f of x. This is the original. So you're looking at this like the same way you normally would. This is not. Yeah, let's stick with it. So when I say identify where, I'm just saying give me the x value. So identify where f of x has a relative max. Relative max is like the top of the hill. That happens at x equals 2. Identify where there's a relative min. Relative min like the bottom of the hill. That happens at about x equals 6. Agree? Where is f of x increasing? I would say from 0 to 2 and from 6 to 8. How do I know that it is the f of x? So this is where we can't say the word it. The word it is banned in this class now. Because I don't know if it means f prime, or f double prime. Can't say it. How do I know f of x is increasing from 0 to 2? Did you say it? The first word you said. going up. It has a positive slope, positive derivative. Those are all kind of saying the same thing, right? Where is f of x decreasing? From 2 to 6. How do I know f of x is decreasing from 2 to 6? Don't say the word f. F of x is going down, or f of x has a negative slope. Wouldn't it also be true that f of x has a negative derivative there? If it's got a negative slope, that's the same idea. Alright, where is f of x positive? So people get mixed up between positive and increasing. I can have a bank account that is negative and increasing. Like you can go negative in your bank account, right? Not ideal, but it can be negative and increasing. It can be positive and increasing. Increasing just means getting bigger regardless of where you are. Positive means greater than 0. Where is f of x positive? 4, how do I know that? Don't say it. Ah! F of x is above the x. Right? Send you guys to the office for cussing. Mr. Gill, I call Mr. Gill. I'm sorry, Trent won't stop saying it. What do you mean shit? No, I mean it. F of x is negative from 4 to 8 because f of x is below the axis. So those are kind of straightforward. Like you could have done that in advanced algebra. What? Third? Wow. Okay. Wow.
Big pen.
Some of us don't have as big a brain. But now we get into the calculus. So where does f of x have a positive f prime? So we have to know what a positive f prime means. So what does f prime tell us? Yeah. So the general idea is f prime of x tells you slope. F double prime of x tells you concave. So if I have a positive f prime, I could really cross out f prime and say, well, that means we have a positive slope. So this is the same question as which one? Increasing. A negative f prime, so again, f prime tells us the slope. So this is basically saying where does f of x have a negative slope? So that's the same as which question? Decreasing. Let's do 6. Questions on those two? Because we just jumped from like apparently 3rd grade to like, AP calculus. Yeah. Alright. Increasing f prime. So, increasing f prime. Again, f prime tells us slope, so I can almost think about just crossing that out and writing slope. What does increasing slope mean to you? Curving up. Increasing slope means curving up, which means concave up. Conk up. So where's this graph conk up? 4 to 8. This is like the hardest thing for most people. An increasing slope, an increasing f prime. So f prime tells us slope, and increasing means the slope is getting bigger. So the slope is curving higher. Decreasing f prime is the same thing. I'm just talking through it the other direction. F prime means slope, so this means a decreasing slope. So your slope is getting smaller. That is concave down, and that is from 0 to 4. I don't know why I didn't put this on there, but let's put point of inflection on here too. POI, but then some people think it's like person of interest. Point of interest, yeah, like a murder suspect or something. So this is where f of x switches from concave up to down or down to up, and what's the x value where that happens? Question on this page. We'll get to those when we get to those. so here's where we change the game a little bit. This is a second derivative graph. So this graph represents what? Represents concavity. So when this graph is negative, again, what does negative mean on a graph? Below the axis. So when this graph is below the axis, the second derivative is negative. If the second derivative is negative, what does that tell us about f of x? Concave down. If the second derivative is positive, f of x is concave up. If the second derivative negative, f of x is concave down. So in these two spots, f double prime is negative. It's below the axis. Because f double prime is below the axis. So if f double prime is negative, which it is in these two spots, f of x is concave down. So in this spot, f of x is concave down. In this spot, f of x is concave down. So then what's got to be true up here in this region where f double prime is positive? F of x is concave up. Which then means, what are these 2 points? X equals -2 and x equals 2. They're points of inflection because didn't the concavity switch at those 2 spots? So let's try, well, we got more to work on too. Okay, so let's go with f double prime is increasing. So this is f prime. So I want to know where f prime is increasing. So if f prime is increasing. Hold on, man. That means f prime has a positive slope. Agreed? Increasing and positive slope are the same thing, right? So if f prime is increasing, f has a positive f prime. If f prime is increasing, f prime has a positive slope. Right? So what does f prime mean? Slope. What does slope mean? Slope. Let me ask this. Aren't slope and f prime the same thing? So aren't I really doing f prime positive? Because I'm taking the slope of f prime. So I'm taking the second derivative of f prime. So this question is asking where the second derivative is positive. That's tough. I mean, getting to that is a lot of levels of understanding and more practice. So that's -2 to 2. I didn't say you were wrong. I was just hoping to explain it to the class. Did I say you were wrong? If I did, I didn't mean to. Okay, f prime of x is decreasing. So if f prime is decreasing, that means f prime has a negative slope. If f prime has a negative slope, then f prime is curving down. That's another way to think about this. If f prime is curving, f is curving down. So basically, this is a level below the original, and this is another level below the original. So we're 2 levels below the original, which is the second derivative. And we want that to be negative. So where is the second derivative negative? It's like -infinity to -2, and 2 to infinity. So then I think these 2 will help you with these 2. So I'm going to give you a second to try those. Think through it on your own without me rambling. Yeah. Yeah, because we got arrows there. So I think the best way to get to these two questions is to start with these two things here. F prime is a relative max. Well, a relative max would mean we're going from increasing to decreasing, right? So we want to know like the peak where it turns around. I know F prime is increasing from negative infinity to negative 2. I'm sorry, decreasing from negative infinity to negative 2, increasing from negative 2 to 2. So at negative 2, what does that create? Relative min. And then F prime of x is increasing from negative 2 to 2, decreasing from 2 to infinity. So that creates a relative max, right, at the top of the hill. And x equals 2. Questions I can answer on those? And again, I know this is not the easiest thing. Alright, identify where f double prime of x is. So I'm looking at the f double prime graph, and I'm asking about f double prime, so I don't have to think about slope or increasing or decreasing or anything. I can just look at the graph. So where f double prime is positive is from negative 2 to 2. And the point of that is to realize that this and this are the same question. F double prime of x increasing equals f double prime of x positive. Same exact thing. And if I want to go another level, what does that mean about f of x? What do these two things both mean about f of x? It's concave. Second derivative positive is concave. Where is f double prime negative? So we're just where is f double prime below the axis? And the point of that question is to help us realize that these two are the same. F prime decreasing equals f double prime negative equals f of x current down, which you guys wrote down on the board, but you were like thinking about it, so I didn't register me much. And then where is f double prime of x 0? X equals negative 2. X equals 2. Point of that is that those are mins or max. So f double prime of x equals 0 are potential. Potential mins max on f prime, points of inflection on f. Potential because it has to cross from positive to negative or negative to positive. If it like bounced off the axis and was 0, if it goes from above to above, that's not a point of inflection. That'd be concave up, concave up. Give me I'm curious your level of how you feel you understood this page. 5 to 1. 5 is good. 1 is bad. Flip me off means don't do that. I will just say it. Alright, cool. Alright, let's go to the next one. So this is f prime. Is it fair enough at this point to let you try it before I talk through it? Have you puts your brain around, doesn't it?
It starts sort of decreasing, right? And then it goes to increasing. So that's going to be up, right? Well, that's increasing. But it starts off decreasing.
Wow.
So it's going to be. So it's going to be. Oh, it's going to be like this. Increasing.
What's that?
Decreasing. Oh, so it's F.
Language in this class.
Oh, because I said the S word.
The I word.
Yeah, but the S word and the I word is the same thing. That's two of the same letters.
Remember when you were in like third grade? You say shh, and I'll say it. You
Yeah.
know that. Rubbing in my mouth.
Trent still does this.
For yesterday.
Hey, really gone.
So you're looking at F prime, right? You have an F prime graph.
Right. Yeah, I'm pretty sure.
So if you want concave up,
Pretty sure it's concave.
so F prime, you want F double prime to be positive. That means you want F prime to be increases. What?
Yeah, no, it's not. No.
Like negative 2 or whatever.
Right. Decrease. What did I say about that? I don't know.
How many would like more time? Did it make you angry?
Yeah, definitely. It just made it.
Wait, it's funny.
Yeah. Yeah, you got. I got to check your mask, and they were. One was I didn't even know about that, and then the other one was get a land on. Yeah, because you
Didn't know about it? What do you mean?
Well, so I just slammed the ball. Didn't know that was a pen. He got like fouled. Didn't know.
From creatine.
Right. So he knew the rule.
So if you weren't so weak in the first place, leading you to take creatine, you wouldn't have been.
Exactly.
No, this is like I took creatine for a while. Young 20s. And yeah, it was. No, it made me angry. It was. Yeah, this physique doesn't happen naturally. That's not. It's not good.
Yeah, well. Take Trent and Sharks.
this graph tells us the slope of f of x. So like, what is f of x doing here? No, f prime is increasing here. What is f doing here?
It's decreasing.
It's decreasing. How do I know that? Don't tell you that.
It's below. Oh. F prime is
F prime is negative.
it's below the axis.
So f of x is decreasing. F prime is increasing. But that's like exactly what Ben just says. The super confusing part. This graph is getting bigger right here. I'm not asking you about this graph. I'm asking you about the original. These are my. So because f prime is negative, that means the original graph is decreasing. F prime positive is increasing, and then you can go over here and say, like, this might help you just kind of organize your thoughts a little bit to answer these questions. So where is f of x increasing? Well, we just wrote that out. So negative 3 to 0, then 3 to infinity. Decreasing from negative infinity to negative 3, and 0 to 3. Relative max. So f of x, so I don't want the relative max of this graph. I want the relative max of f of x. So relative max of f of x happens when f of x changes from, if it's a max, it changes from 1 to 1. F of x changes from 1 to 1. Increasing to decreasing. So that happens right there. Right? F of x is increasing before this point, which means we're getting bigger. X is decreasing after. So x equals 0 is a relative max. And that's what I was trying to write out over here. F prime goes from positive to negative, which is above to below the axis. That's a relative max. Relative min, F prime goes from negative to positive, or below to above the axis. So there's two relative mins, right? Negative 3 and 3. Okay, well now I'm asked about concavity. So concavity comes from which level? The second derivative. I'm looking at the first derivative. So I've got to go like down a level. How do I go down a level on a graph? How do I take the derivative of a graph? What do I look at? The slope of it. So if I look at the slope of a graph, that's essentially like interpreting its derivative. So I've got to go down a level from here. So concave up means when I go down a level, by taking the slope, I want that slope to be positive. So where is the slope of this graph? And again, so there's like two levels of this. Some people really think through, kind of like I'm talking through now, like this means this, which means this. And they're really good at tying that stuff together in their head. Some people just are like, look, you have these rules here. I remember them, and you use those. And it doesn't matter to me which way you use. But concave up, right there, is the same thing as the derivative as f prime of x increasing. So like if you're someone that's like, hey, I can remember all these rules, I can throw those, and they're easy. Like once I can see them, I know what to do, and it works. Some other people like to think through kind of the logic of it. But concave up means the derivative needs to be increasing, which happens from negative infinity to, I don't know, let's say 1. Is 1 fair there? Oh yeah, negative 1. Okay. 1 is not accurate. And then also from, I guess, 1 to infinity. And that's the same thing as f prime increasing. Concave up, f prime increasing are the same idea. And then concave down is f prime decreasing, so that'd be from negative 1 to 1. Are there any points of inflection? I got a couple ways to look at it again. I don't even know if that's up here. Okay. Point of inflection is where f double prime changes signs. So, well, I don't even. That doesn't really help here. But where do we switch? We got concave down and concave up, right? So isn't it down up until -1 and then up? So isn't -1 a point of inflection because it switched? And then 1 also because it switched. Alright, I'm asking you about f double prime again. F double prime is positive. Well, I already answered that question. How did I phrase it earlier? Like in the same page. Like 30 seconds ago. Yeah, concave up. Yeah. Sorry, I kept interrupting your answer. So this is the same as concave down, and then this is the same as points of inflection. This is good. Try that number 1 right there. Oh, good question. Why are you like a horse? This is fx. The slope of a straight line could be anything. Because every single line is straight.
What's the slope of a horizontal?
0. 0. If you really want to piss me off, just say it is. It is a straight line.
Well,
It double prime is a straight line. Were you asking a question or were you trying to explain?
oh no, I was trying to understand which side is the
Okay. So, you do not know the actual numbers here, but you know enough to put them in order for basically you can tell if they're positive, negative, or 0. All of them. So f of 0 is just the y value at 0. And that is, I don't know what it is, but it's a positive number. Agreed? That's just what's the y value. Sure. Whatever. Point 1. Doesn't matter. F prime of 0. Well, what does f prime have to do with f of x? It's the slope. So what's the slope at this spot? 0. F double prime of 0. Well, what does f double prime tell us? Concavity. It's curving down, the slope of the slope. It's concave down, so f double prime is negative. And again, I don't know the number. But that allows me to put them in order from biggest to smaller. Right? So then it's actually just the same order as they are. So f and then f prime and then f double prime. So that would be
well, like, isn't like if f prime at 0 is just like 0, then how is there any slope to that at f double prime? It's concave down. It's concave down.
say your question again.
If the slope, or if at f prime is 0 is just like this, then how is there any slope to it at f double prime?
The slope would be 0. So it would cross that. It would be on the axis. So if I got f prime here, f prime would be like this. And then f double prime would be like this. No, sorry. More like this. this. I didn't answer your question at all. Let's say that's f of x. F prime would be there, be like this. So there's where your slope is 0. And then f double prime